Okay, guys, today we're going to talk about significant figures and measured numbers. So this is the first lesson when we talk about numbers in science, and we're going to see how we treat measurements when we do this in science. So it's important to know. All right, so let's just say you have a bathroom scale, okay, and you step on that bathroom scale one day and you want to check your weight. So if you read where the needle is here, and this is 150 and this is 155 pounds, and your needle ends up somewhere in there, let's just say it ends up there, and we read this, we can get a what would you say? I mean, I would say maybe 153, maybe 152, maybe even could say 153.5, maybe 153.50, maybe. I mean, you can come up with these various measurements from this. But what's important to understand about these measurements here is that we know for sure that it's at least 100 pounds, right? Because the scale is giving us that number. We can be sure that the instrument is also making sure it's at least 150. So we know this digit, and we know this digit, and we know this digit, and we know that digit. The problem, however, is this third digit, because this is really the one that we're guessing. That's not sure. We're not sure what the guessing is on that one. That we're not sure. Okay. And then we're going to estimate that number. So 153 is fair enough. 152 might be fair enough. Okay. But how can you actually guess this one if you don't know what this one is? So if you don't know what the 3 is, if you have to guess that 3, then how do you know the 5? So we can't use this as a good measurement. Okay, that's not something we can really base our numbers on, or base any calculations on, because we really don't know the number for it. So we can be sure of this number and this number. This is the one we have to guess, which means we can't use these numbers. Okay, so there are numbers and measurements we can't use and some that we can use, and that is really the subject of what a significant figure is. Okay, so really, what's a significant figure? The easy way I think is to think about it as a measured number. Are you measuring the number from the instrument? Okay, so in a measurement, all certain digits. Okay, so again, you have to realize that this is measurements. All certain digits, ones you cut from the machine that you're using, plus the first uncertain digit, are something called significant. And that's they have meaning. Okay, these have meaning to them, to the measurement. Okay, which means significant. Significant means important. I like to say measured numbers, significant figures. Okay, all right, and just remember that counting numbers. If I say there's 27 students in the room, or I have 3 apples, okay, those are not significant figures because I'm not measuring them with an instrument. They're not. Okay, chemical definitions or scientific definitions, such as a liter is 1,000 milliliters, are not significant digits either. Okay, so these are definitions, and definitions won't apply. All right, so a couple of rules that you want to be, and like I said, different teachers will have different ways, and different textbooks will have different ways. I think this is the easiest way to do it. Again, you can look up different ways or talk to your teacher about that if that's the case. But all non-zero numbers. So for rule number 1, all non-zero numbers. So that's anybody 1 through 9. Okay, numbers 1 through 9 are always significant when you see them in a measurement. So whether it's a 1 or a 5, you would find that's true. So some examples: 123.9 centimeters. These are all measured numbers. Okay, 67.8 millimeters, measured numbers. 23 miles, measured numbers. So there'd be 4 sig fig here. Okay, there would be 3 sig fig here. There would be 2 sig figs here. Okay, so that's the important thing to know about these non-zero numbers. Okay, what the problem is, it's going to be zeros. Zeros always present the problem to us because sometimes zeros are measured and sometimes they're placeholders, and that's the key. So if you have a 0 that's in between other numbers, I call them sandwich zeros. So they're in between. So in between zeros, in between. Okay, if they're in between zeros, I call them sandwich zeros. These are always going to be significant because if you have a situation like 2,202 feet, since this is a measured number and this is a measured number, the only way you can measure the 2 is if that you know that 0 is a measured number. Otherwise, you would never measure it. So that's important to know. So sandwich zeros, again, zeros in between other numbers are going to be always significant. So you'd have 5 sig figs here. Okay, here you would have 2 I'm sorry, 4 sig figs, but you'd have 2 internal zeros or sandwich zeros. Okay, and here you would have 3 sig fig. Okay, and you call them sig figs. Okay, so again, what is a significant figure? A significant figure is a measured number. Okay, and so in this last example, the 1.003 grams, if you're measuring the 3 and you know that's a 3 on your instrument, then you would have to know this, and you would have to know this, and you would have to know this because you're measuring successive decimals. Okay, now of course zeros can be in the middle, they can be at the end, or they can be in the beginning. Okay, now leading zeros, okay, leading zeros are never significant, and we like the word always and never because we can kind of memorize it that way a little bit. Okay, so leading zeros, a good example of a leading zero is 0.000008 centimeters. Now again, this is the number I measured, so that's okay. However, how do we know when we write this down where that place is in the decimal world? The only way to do that is to fill the spaces before that with zeros. Okay, so while these zeros are here, these zeros would not count as sig figs. Okay, so this would only have 1 sig fig, 1 measured number. Okay, and again, it could be a little confusing because you make the argument that, hey, I measured these, but you didn't. You actually measured the 8. This is what you measured, but these are what telling you where you are in the decimal world. Okay, again, sometimes you may even say 0.1. I mean, some people don't even write the 0 before that. So this 0 simply just tells you where the decimal point is. It's not measured, so it's not perceived to be that. So this would be 1 sig fig. Okay, if you have 0.00102 miles, okay, well, wait a second. Remember, there's a sandwich 0 here. That's going to count. However, these don't count for as far as significant figures. Now, please realize that I'm crossing them out. I'm not crossing them out because they're not part of the number. They are. It's just they don't have any measurement meaning, and that's the key here. Okay, so you have 3 significant figures here. All right, so watch your zeros. So zeros could be in between other numbers. They're always significant or measured, or they can be starting in front of any number. So the starting zeros in front of the first measured number are never significant. Okay, so that's important. Don't count them. All right, now the only thing left to do is to make a decision is when you have a trailing 0. Now a trailing 0, okay, and we're going to use trailing as your example. So trailing are only significant when you have a decimal point present. Okay, so this is where you're going to have to make a decision. Okay, so really important. So for example, I have 123.00 centimeters. Okay, well, the 123 we know is significant. However, whoever measured this took the time to measure the extra 2 zeros because they're trailing the last significant figure. All right, and if that's the case, then these would also be significant. This is significant, this is significant, 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 significant. Otherwise, I would just write 1, 2, 3, right? So why do we write 123.00 versus 123? Why can't I express, are they the same? Well, they're the same numerically, but this has more meaning because it's more precise, right? You're going to the 2 extra zeros. So this would have 5 sig fig. That's because the person who measured this measured to the extra 2 digits. Okay, 1 millimeter. I mean, what's the difference between 1 milliliter, 1 millimeter, 1 millimeter, or 1 millimeter? Nothing. But what's different about the measurement is that someone decided to confirm the fact that the measurement is 0 here. So these are measured numbers. This would have 4 sig fig because of the decimal point. Okay, 500 miles, right? Well, if I said, central office is 500 miles away, or, my grandmother lives 500, let's just say my grandmother lives 500 miles away. Is it 500 miles? Is it 502? Is it 503? If I just say 500, I'm not giving you a very good measurement. But if I say 500 point, that means I measured the 5, I measured the 0, and I measured the 0, and I'm exactly 500 miles to the nearest single mile. So this again would have 3 sig fig. So if that decimal point is present, then you know for sure, okay, that these zeros are significant. Okay. Last but not least, measurements written in scientific notation have digits which are all significant. All significant. Okay, the times 10 part of scientific notation is not part of this because all that does is tell you where the decimal point is. Okay, so for example, if I had 6.780 times 10 to the negative third centimeters, that's just telling me I have 6.780 and I'm moving the decimal point 1, 2, 3 places away, right? Correct? So that would be 0.000678. Again, leading zeros are never significant. Trailing zeros with a decimal point are. So this is your significant part. So I would only have 4 sig figs here. Okay? So that's pretty cool because scientific notation really helps us, right? But this is not the significant part of the number because it's not measured. Those are just driving directions for your thing. So to review, non-zero numbers, 1 through 9 are always significant. Sandwich zeros, always significant in between other numbers. Leading zeros, which means zeros before measured numbers, never significant. You don't count them as far as a measurement. Trailing zeros, just check that if you have a decimal point. If you have a decimal point present, anything after those numbers, anything trailing would be significant. Okay? That's important. So a number like this, if you had 20,000, these would not be significant. You'd have 1 sig fig here because there's no decimal point. Okay? All right, cool. So let's move on a little bit. Let's do some practice. All right, so how many sig figs here? I'll pause for a second. I'll let you do that on your own. So if I pause here for a second, I'll let you look at this one. Quick pause. If you said 4 sig fig, you'd be right. Okay, maybe you want to try to do this and then check the answers here. Okay, because you have sandwich zeros. There's your sandwich. Okay. Okay, next one. If I had this one and I said, if I said 0.0045, those are leading zeros. They're not going to count. Only the 4 or 5 counts. I would say 2 sig figs. Okay. 34.7. Well, there's 3 significant figures. They're all non-zero, so I'd have 3 sig figs here. Okay. Now, take a look at this one, 1.3000030 pounds. Okay, well, these are all sandwiches. That's a sandwich zero. And this is trailing, but it's trailing with the decimal point. So I'm going to take all of these to be significant. I'm going to have 5 sig fig here. Okay. 0.00306 feet, sandwich zero counts, 3 counts, 6 counts. These are leading. They don't count. 3 sig figs. Okay. Now, 800 kilograms, let's just say I weighed an elephant, and the elephant was 800 kilograms. There's no decimal point here. So this could be 802, it could be 803, it could be 805. Maybe I don't even care. I know it's about 800. So because of that, it's not giving us a lot of information. It's not kind of a lousy measurement. Okay. Maybe I don't care if it's lousy. Maybe I just want to know about how much it is. Well, that means I'm just going to worry about the 8. I'm not going to worry about those trailing zeros. 1 significant figure. Okay. Quick little story. Let's just say you went to the doctor to review this. Let's just say you went to the doctor and your doctor measured your heart valve to be 5 centimeters. And you went to another doctor and your doctor measured your heart valve and the heart valve was 5.0 centimeters. And you went to another doctor and he measured it to be 5.000 centimeters. And you wanted to make sure your heart was healthy. Which doctor would you go to? Dr. A, Dr. B, or Dr. X? Okay. Well, you probably could say, I would probably go to Dr. X here because Dr. X is measuring that heart valve to a better precision. Okay. He's making sure that your heart valve is measured correctly to the correct thousandths of a centimeter. Where this Dr. A, you probably don't want to go to him because he's measuring your heart valve to the nearest single centimeter. I mean, could your heart valve be 5.3? Could it be 5.4? It could, right? But you won't know that because you only measure it to a 5. And that's why this is important. Measurements are important. Now, as far as your calculator goes, okay, your calculator doesn't understand this. Your calculator is clueless, right? Your calculator doesn't understand. Calculators just think this is 5, 5, 5, and 5. Okay, so you have to understand what it really means. Okay, so in this case, you might have to be asked to round too. Round to the correct number of, so use the regular rounding rules. If you have 65 grams and you want to round it to 1 sig figs, well, right now this has 2. So we're going to round it to 1. So we're going to take the 5 and we're going to round it up. Okay, and we would round the 6 to 7 but we have to fill that decimal place with a 0. So this would round to 70 grams. Okay, again, you have to hold the place. So one significant figure, the trailing doesn't count. Okay, 26 centimeters, 26 centimeters, I would round that up, round this to 30 centimeters. Okay, no decimal point. Okay, if I round this to 33 significant figures, I would take the 6, round that up, and I would get 45.4 millimeters. Again, I don't want to add a 0, because if I do that, there's a decimal point, and I'll have 4 significant figures. I only want 3. Okay, 202.6, I want to round it to 3. I would say 203 kilograms. Okay, so that would go up to that. All right, and last but not least, if I've given a number, this crazy number here, circle the digits that are significant figures. Well, again, this is significant, correct? Because that's sandwich. Sandwich sounds good right now. And these ones here, these trailing, are going to count, right? Because the decimal point is present. Okay, these are leading zeros. They're not going to count. So we're not going to count those. So yes and yes. Okay, so that ends the show on significant figures. What we'll do in the second video is talk about the operations that we're going to use with significant figures. Okay, so we'll see you back in a little while.